Hello, good morning my dear students. Welcome to digital classes. This is chemistry period class +2 as we are doing unit 2 solution. So today we are going to start our topic colligative properties and determination of molar mass using colligative properties. So dear students, as in previous video already we have discussed about the colligative properties and what is the meaning of colligative. Colligative word came from two. If we will break the colligative, it is coming co and ligate. Co mean together and ligate is to bind. So it is the properties of solution which depend only on the number of solute, not the nature of solute. Okay, so it is the number of solute which change the properties, that is called colligative properties. And as we know that in a general solution is made up of solvent and solute. So particularly colligative properties, we are discussing all the four properties in which inside a solvent there is a non-volatile solute. Now what is volatile and non-volatile solute? Already we have discussed in previous topic, that is volatile solutes are all those solutes where liquid is itself solute which dissolve in solvent, and other than liquid it can be solid or gas. Those kind of solute is known as non-volatile solutes. Okay, so yesterday we have done relative lowering in vapor pressure, which is the change in vapor pressure, delta P. Delta P can be derived, or we are finding out the molar mass of solute in P1 naught minus P1 upon P1 naught is equal to delta P1 upon P1 naught. So according to this formula, we are going to derive the relative lowering in vapor pressure. The meaning of relative lowering in vapor pressure is yesterday we discussed. It is the when there is non-volatile solute is added in the solvent, then what is happening? The vapor pressure of solution is going to be decreased rather than the decrease as comparison to the pure solvent and solute. Okay, so after calculating this from the Rod's law, we started this derivation and we got that x2 is equal to delta P1 upon P1 naught Pi naught. It is that P1 naught minus P1. Delta P1 is P1 naught minus P1 as from this formula upon P1 naught. And sometime question is coming, find out the molar mass. So here I want to tell you about some of the numericals are coming from related to this derivation. So we will discuss one numerical before going to move for the next topic. That is, as it is given in this example, the vapor pressure of a pure benzene. Benzene is solute now. Solvent here at a certain temperature. This is the pressure, 0.850 pressure of this benzene. But when a non-volatile, non-electrolyte solid will which is the weight 0.50 gram is added in this much gram, 39 gram of benzene, which is solvent, whose molar mass is 78 gram per mole, the vapor pressure of the solution, the mixture of benzene and the non-volatile solute, it becomes solution. You can see the vapor pressure from 0.850, it will become now 0.845 gram. It means that it decreased, it lowered the vapor pressure. So always, what is colligative property? It always lower the vapor pressure when a non-volatile solute is going to be dissolved in a solvent. Okay, so you need to calculate the vapor pressure of the solution and what is the molar mass of the solute. So we need to specially find out the molar mass. As formula we will write the MV. Okay, so that's why this formula we are doing. This formula we will calculate M2 is equal to W2 M1 upon W1 P1 naught minus P1 upon P. So it is first task to calculate this P1 naught upon P1 now. So according to Rod's law, P1 naught minus P1 PA, here 1 is written in place of A, so don't be confused. There we have written 1, here we are writing A, upon PA naught is equal to XV is equal to WB into MA upon MB into WA, whereas MA is the mass of benzene 78 and MB is the mass of non-volatile solute. Okay, so WB is, we will write first step of the numerical is given. So WB is the mass of non-volatile solute, that is 0.50 gram. WA is mass of the benzene solvent. PA is the vapor pressure of solution. PA naught is the vapor pressure of pure solvent. So when we will put all these values in the formulas, we will get the value. This is the value, only we don't have MB, so we will replace by, after reshuffling, the value MB is equal to 0.5 into 78. This will go up into 0.850 and this will come down 0.005 into 39.0, from where this 0.005 came, as we will change this into kilogram. Okay, so after this we are getting the value 1.170 gram mole inverse. So dear students, while watching this video, please go through this numerical and practice this numerical at home. Okay, so like this way, when we have done the relative lowering vapor pressure and we come to know now, once we need to find out the derivation, then we need to use this formula and we need to calculate some of the numerical. Okay, in exam also this will come in this way. Now let's move forward for the second colligative property. The name of the property is elevation in boiling point. Elevation mean increase, so increase in boiling point. It means that when non-volatile solute we are adding in solvent, the solution will have more temperature as comparison to pure solvent. So this relation we will do here. The formula delta TB is equal to Kb into W2 into 1000 upon M2 into W1. You know very well about what is Kb. So let's discuss. When the addition of non-volatile solute to a solvent, the vapor pressure, the boiling point of solution will increase. Okay, the boiling point of solution will increase, very important line. And boiling point of a liquid is what? It is that temperature at which its vapor pressure become equal to atmosphere pressure. So sometime definition is coming. What is boiling point? It is a liquid. Generally you have studied, it is that point where water is the liquid is going to be start boiling. It is not the perfect definition. The perfect definition is boiling point of a liquid is that where temperature at which its boiling point become equal to the atmospheric pressure. So boiling point of solution is TB. Boiling point of pure solvent is, we will write TB naught. Elevation in boiling point is delta TB. Delta is always, wherever delta is written, it is showing the change. So how we can find out the changes? It is very simple, final minus initial. So delta TB is equal to TB, boiling point of solution, which is final, minus boiling point of pure solvent. So experimentally determine delta TB is proportional to molar mass, so mole fraction. So it is delta TB is equal to Kb into M. So Kb is the proportional, which is called molar boiling point elevation constant, evaluoscopic constant, very very important. And the unit of this is Kelvin kilogram mole inverse. And when we are finding molar, you know the molarity. The molarity is W2 into 1000 upon M2 into W1, as we have done in base to express the concentration of mass. Already we have done. So from here, now the value of M we will put from here, the equation in equation 1, the value become delta TB is equal to, you can see Kb. Kb is already there. And then after that W2 1000 upon M2 into W1. Hope so you understood. Nothing we did. We just replaced this value here. Okay. And after that, by shuffling, sometime the question is coming, suppose M2. So here also mass, if the molar mass they will ask, the molar mass can be Kb into W2 into 1000 upon delta TB is replaced with M2 into W1. By using this formula you can calculate the any numerical. Okay, one numerical we will discuss, we will practice now. So for example, this example we will take to discuss the numerical related to elevation in boiling point. The numerical is boiling point of a water at 750 mm of Hg is 99.63 degrees Celsius. How much sucrose is to be added to 500 gram of water such that it boils at 100 degree Celsius, where Kb of water is 0.52 Kelvin kilogram. So according to formula, since boiling point is changing, apply the formula for elevation boiling point. As we are discussing elevation boiling point, so this formula is applying. But here M is Wv upon Mb into Wa into 1000 is also there. So delta Tb is equal to Kb into Wb, it will go up, and Mb into Wa. So Kb is the evaluoscopic constant. So Wb is need to be calculated. So we will replace Wb is equal to with Tb, delta Tb. All the equation will reverse. Mb upon W into Wa upon Kb will go down. So delta Tb is Tb minus Tb naught, as Tb is the boiling point of solution and boiling point of pure solvent. So these are the givens. Mass of water is given, which is 500 gram. If we will write in kilogram, it will become 0.5 kilogram. And elevation in boiling point we need to find out. So 100 degrees Celsius minus 99.63 degree Celsius, which is given here. 9900 degrees Celsius is given, and 9963 degrees Celsius to 100 degree it will reach. So how much change observed, that is 0.637 degrees Celsius, which was 0.37 Kelvin. Molar elevation is value is given in book. So molar mass of sucrose is this. We need to find out molar mass. This is the molar mass of sucrose now. So it means that we need to we get Mb, we have Kb, we have delta Tb, we have Wa. So what we need to find out? Wb. Okay, although formula is to calculate Mb is equal to Wa upon this, what we can replace this, and Wb is equal to Mb. Put the value of Mb, which is this 342, into delta Tb. Put the value of delta Tb also 0.37. Wa, put the value of Wa 0.5 here, and upon Kb, put the value of Kb here. After calculating, you will get this. So these are the very simple type of numerical. You just have to know 3 steps. First step is read the numerical carefully, what is given in that numerical and what is the formula we have, then how you relate the given with the formula and how to put the given into the formula as we have put here one by one. Then after that you need calculation, that is mathematical part. Okay, once you know, you will follow all the 3 steps, definitely you will come to know how to do this numerical. So dear students, here I want to appeal you, the numerical is very important part. It is coming in your exam also. Numerical is specially asked from first unit, second unit, third unit, fourth unit. You need to be very much practical about the numerical. It is physical chemistry, so without numerical you cannot score high marks. Okay, so dear students, this is we have done today elevation in boiling point up to this, and after this we have done the numericals. Now next is depression in freezing point. There is very small difference in elevation and depression. What is that? Let me tell you. Delta TB, delta F. B is boiling, F is freezing. You know very well, boiling is increasing temperature, freezing is when decreasing temperature. So when we will add non-volatile solute to a solvent, the freezing point of solution will decrease. Okay, it means that what is freezing point? It is the temperature, like this same way at which the solid and liquid state of substance have the same vapor pressure. Solid and liquid state of the substance have same vapor pressure. As we did boiling point of solution TB, here is freezing point of solution TF. Boiling point of pure solvent delta TB naught, freezing point of pure solvent TF naught. Elevation of boiling point delta TB, here depression in freezing point delta TF. So delta TB is TB minus TB naught, here delta TF is TF naught minus TF. Experimentally it is delta TB is inverse proportion to direct proportion to molarity. Here also TF is direct proportion to molarity. Here KB, KF. KV is evaluoscopy constant, KF is cryoscopy constant. SI unit is same, formula is same, only in place of KB, KF, in place of delta TB, TF, delta TF. The numerical will also be done in the same way. So today, now we did elevation boiling point and depression in freezing point. Yesterday we did relative lowering vapor pressure. In this way, basically 3 colligative properties we have done. Now 4th is osmosis and osmotic pressure, that we will discuss.